Alrighty, this is Euclid Book 3, proposition number 35, if I recall correctly. Yes, it is. It's Euclid Book 3, proposition number 35. And Euclid says the following. He says, if you have two straight lines in a circle, and we have two straight lines here, we have one that's called AC, and we have another one that's called BD. And he said, if they cut each other at a point called E, then the rectangle contained by lines AE, EC. Well, where's AE? Well, here's AE here, and here's EC here. The rectangles contained by those two lines there, or the rectangle contained by those two lines there, is exactly the same size as the rectangle contained by DE, EB. Well, where's DE? Well, DE is right here, and EB is right here. Alright, I'm not exactly sure where they get the rectangle part of all this, but the proof is pretty simple. Every one of these lines right here are equal in size. Why? Because they pass through the center of the circle. So for part one of this proof, it's pretty simple. Okay? Every line here is equal in size, so therefore you have not just two rectangles, you actually have two squares, okay? Because every line here is going to be equal in size. Therefore, in this particular case, the rectangle contained by AEEC is going to be exactly the same size as the rectangle contained by DEEB. But if you notice, I said this was part one of the proof. That's right, there's going to be yet another part of this proof. Hopefully that will illustrate a little better the point that Euclid was trying to get across. But for this part of the proof, like I said, it's real easy. AE and EC and DE and EB right here all are radii of the circle ABCD. Therefore, the rectangle contained by AEEC is exactly the same size as the rectangle contained by DEEB. I will cover the rest of this proof in another video, so stay tuned.